Let's talk about something we almost never see but rely on every single day: foundations. They are the invisible, unsung heroes holding up pretty much every building you've ever set foot in. So, we're going to start with a pretty simple question.
No, really think about it for a second. The chair you're sitting in, the floor, the whole building, what's actually stopping all of it from just sinking into the ground? The answer is a never-ending fight against one of the most powerful forces out there: gravity. You see, every single structure, whether it's a little shed or a giant skyscraper, has this incredible weight. And the number one job for any engineer is to figure out how to take all of that weight, all of that load, and transfer it safely into the earth. If you get that wrong, the building could crack, it could lean, or it could even collapse. And that's exactly where foundations come in. Okay, so let's start with a really basic problem. Imagine you need to support something that's long and heavy, like a big brick wall. How in the world do you hold up that entire thing so that no single part of it starts to sink? Well, you're going to need a continuous solution.
And that solution is the strip foundation. The best way to picture it is to think about a ski. If you just stood in deep snow with your boots on, you'd sink right in, right? But a long ski spreads your weight out, and suddenly you're gliding on top of the snow. A strip foundation is basically a long concrete ski for a wall. It spreads the wall's weight out evenly along this continuous ribbon.
And that right there, that's a core principle of engineering. It is that simple and that direct. If you've got a wall, a long spread out load, you use a strip foundation. That's rule number one.
Okay, that makes sense for walls. But what if your building isn't held up by long walls? What if all that weight is focused on just a few specific points, like on individual steel or concrete columns? A long ski wouldn't do you any good here. You need a totally different approach. You need an isolated solution.
And that is where the pad foundation comes into play. So if the strip foundation is a ski, you can think of this one as a snowshoe. It creates this wide, stable base directly underneath one single point of intense pressure: your foot, or in this case, a building's column. It takes that super concentrated load and spreads it out over a bigger area, so it doesn't just punch a hole straight into the ground.
And there it is, rule number 2. Pad foundations support columns. You see the pattern here, right? The shape of the foundation is designed to perfectly match the shape of the load it's holding up. Long walls get strips, single columns get pads.
So we have our two main players, the strip and the pad. But now we get to the really important part. How does an engineer actually choose which one to use? This isn't just a random guess. It's a super critical decision that's based on cold, hard facts.
That's it. This whole complex-sounding engineering decision really just boils down to understanding two things: the load coming from the building and the soil it's all going to sit on.
And what's great about this is how clearly it lays out the logic. Over on the left, everything about the strip foundation is about being continuous and distributed. And on the right, the pad foundation is all about dealing with isolated, concentrated points of weight. The choice always starts with figuring out exactly what it is you're trying to hold up.
So the first factor is the load. And this is more than just how heavy the building is. It's about how that weight is being delivered. Is it spread out nice and easy along a wall, or is it focused like a laser beam right through a column? Understanding the load is step one.
And the second factor, which is just as important, is the soil itself. What is the ground actually made of? Is it solid bedrock that can take a ton of pressure, or is it soft clay or sand that can't really hold much at all? The ground's ability to push back against that weight, what they call its bearing capacity, is a total deal breaker. So how do engineers put it all together? Well, they follow a really clear logical process. First, they identify the type of structure. Are we dealing with walls or columns? Then they analyze the load. After that, they test the soil to see how strong it is. And only after they've done all that can they confidently pick the right foundation, making sure that building will stand safe and sound for decades to come.
And that's really what this is all about. This simple choice between a strip and a pad foundation is one of the very first and most important decisions in all of construction. Because if you get the foundation wrong, everything, and I mean everything you build on top of it, is at risk.
So look, if you only remember 3 things from all this, make it these 3 lines. They're like the bedrock principles of this whole thing. Strips are for walls, pads are for columns, and the final choice always comes down to a careful calculation of the building's load and the ground's strength.
So the next time you walk into a building, just take a second, look at its structure.
Do you see long, solid walls, or do you see a grid of individual columns? Because now you have a pretty good idea of the kind of invisible engineering that's holding you up. You can ask yourself, what unseen foundations are you standing on right now?